Okay, so in order to prove to you that the definitions of what we used in the previous part of the video comes from here, okay? So we use the BIBO stability in using this example. Alright, UK is equals to A1, or this is A1, UK minus 1, alright, B naught EK. Alright, this is something, so previously our A1 is some value, B naught is some value, right? So in order to do this, the first step is is to prove lah. Okay, so we are proving it now. We are not doing the problem now. Okay, is that EK, alright, is equals to 1 when K is equals to 0. When K is not 0, it is 0. When you see this thing, what does this mean? This is talking about impulse response. When K equals to 0, you have a impulse bang, right? And then the rest are 0. That's all it is. Alright, so when at K equals to 0, or you have an impulse all over here. That's all it is. Okay, so your EK will be that. So how can we use this thing, alright, to actually prove to us certain stuff? You have your A1 UK minus 1 plus B naught EK. Alright, so it's equals to UK. I'm rewriting this thing all over lah. Okay? So if u is 0, for example, if k equals to 0, alright, then u is 0, right? Because equals to 0. So equals to A1. If k equals to 0, I will have u0 minus 1 plus B naught EK equals to 0, so you have E naught. Correct? So over here, the next step is that I'll continue to write the u naught over here, while u minus 1, or u minus 1 is a step, if you think about the time domain. So in the time domain, this is the magnitude, or this is whatever thing that is, alright, I think it's your magnitude lah, okay? So everything start from time equals to 0, right? If you remember your causal, alright, so this thing over here is, so normally the digital signal are all in terms of a causal system, alright, where you start your signal whenever it is 0, alright, when time equals, because when time is equals to -1, you're talking about this place over here. You wouldn't have any time equals to -1, right? Unless you're talking about non-causal, where you store your information first. Over here, this is at the present moment, at the present time. Alright, if you have something that is behind time equals to 0, this means that you are storing certain particular signals, alright, in order for translation into because this is input, alright, so you have a certain output. Alright, so this point over here will be plot over at this side. Alright, is it? Yeah, and then this point over here will be plot. Maybe I shouldn't have said that. Alright, this point over here is plotted at this side. This is the first point, alright, and then the second point is plotted over at this side. The third point, etc. So over here, up to here, this is the last point. Alright, so you send through all the signal. So if you're going to send the next signal, the future signal, then you're going to talk about the future signal over here, right? So this is something that you need to know about, and if you want to know more, you can go to this video on l6v7, concept of causal and non-causal, and you can also watch the extra one, talking about the concept of visualizing the future signal. Okay, talk about causal and system also. Alright, but nonetheless, let's come back to where we are. Where are we now? Okay, so therefore, we know that u minus 1 shouldn't exist, right? Because we're talking about causal system. So causal system, we don't need u minus 1. We don't need any time that is before time equals to 0. Alright, so time equals to 0. We don't need any signal all over here. So our u minus 1 is over here. Alright, so there will be some signal over here, your A1, right? As what we have seen. Yeah, your A1, your constant is A1, your coefficient is A1. So we don't need any A1 at all, right? Because it's u minus 1 now in this particular scenario. So this is before time equals to 0. So we don't need this anymore. So we just set it as equals to 0. Alright, so we only one time is equals to more than 0, then we are looking at that. Or when time is equals to 0 onwards. So over here, your u minus 1 will be cancelled. Alright, so this thing over here becomes as 0. Alright, plus your E0, when when k equals to 0, you have an impulse of 1, right? So E0 is equals to 1. So I have 1. 1 times B naught is equals to U naught is equals to, now call the B naught. Alright, and this is why we have it over here. Okay. Next, if I have a UK is equals to A1, right, I'm simply rewriting this term again. Now if I have, instead of k equals to 0, I have k equals to 1. Alright, k equals to 1, I have U1 is equals to A1. Alright, so k is equals to 1. 1 minus 1 is 0, so I have U naught. Alright, A1 U naught plus, when B naught, alright, E is 1, right? So 1 over here. Alright, so impulse only when k is equals to 0, as shown over here. So over here, when k is not equals to 0, then the impulse is simply 0. So this thing over here is 0, because E1 talks about when k equals to 1. Your impulse when k equals to 1. When k equals to 1 is over here. Alright, over here this is not impulse, these are all zeros. I just said it, right? So therefore, since k equals to 1 is 0, so the impulse, since k equals to 1, alright, so k is not equals to 0, right? When k equals to 0, when k is equals to 0, it is 1. When k is not equals to 0, everything becomes 0. So if k equals to 1, then it's 0, right? Because it's not 0. Like macam, right? A lot of 0, 1, whatever. But think about it, just take a second and think about it. Alright? Because my k is equals to 1. Alright, in order to be 1, in order to have an impulse input, your k must be 0, and that's it. So this is equals to 1. So therefore, you wouldn't have anything like this. It should be 0, right? And that's all lah. So you wouldn't have any impulse. So this whole term becomes 0. You'll have A1 U naught, which is over here. And you know that your U naught is equals to your B naught. So over here I'll have A1 B naught. Alright? And the next continuous step, you just do it yourself. Or you will eventually prove that you have A1 square B naught, A1 cube B naught, etc. So therefore, this thing over here, if you were to do a summation, you'll have somewhat like a A1 K, alright, B naught. Summation from k equals to 0 to infinity. Alright, magnitude. And what I'm written over here is this thing. Alright, and this thing over here describe this all thing. If I were to go from k equals to 1, this is 1. 1 is when k equals to 1 So sorry, yeah. So I should say that when k equals to 0, alright, when k equals to 1, k equals to 2, k equals to 3, all the way to k equals to infinity. So this whole range that I'm talking about is talking about this being summarized within this initial notation system. Okay, so I think I'll just paste it in the pane. But anyway, so this thing over here, if you remember, comes from where? Comes from all the way up there. Up where? Up somewhere there. Up here. Aha. Alright, this thing comes from your BIBO stability just now, right? Your summation of hk must be smaller than infinity. Alright, so therefore your summation of hk, alright, is equals to this thing. The one that we have just written. It must be also smaller than infinity lah. Okay? By any of the case, alright, let's just come back to here. Alright, it's the same thing. But I just want to let you know that this thing is the BIBO stability video. If you haven't watched it, you can just watch the l6v7, alright, where we talk about that particular stuff lah. By any of the case, let's just continue. Alright, just continue. But anyway, so I have this thing I have proved to you already. Next, I'll factorize out my B naught. Alright, I'll just bring it outside. Okay, and I'll just put this magnitude over here. Okay, and what I have just done is this thing. You see, it's the same thing. This thing over here is the same as this. Correct? So actually, that's what I'm doing right now lah. So I'm proving to you that this is what I've just done lah. Okay, I just simply factorize out the B naught, because the B naught is just a constant, the AK is changing. So this thing over here, think about it. This is your geometric series, alright, as shown by this dude over here, geometric series. So your A1K can be rewritten as 1 over 1 minus A1, sorry, 1 minus A1. Yeah, 1 minus A1. Okay? So that's all lor. So 1 minus a1. And next, I think I'll clear a little stuff because it's really messy right now. Okay, I'll just clear a few stuff. As uk is equal to 0 for, wait I don't know what this sentence for, when uk is equal to 0 for k is larger than 0. So I think this summation is all the way from k equals to 0 to infinity lah. That's all lah. But anyway, let's continue. So we last stop here and we say that this thing over here is a geometric series. So therefore I can just rewrite as b0 1 over 1 minus a1, right? Your a1, right? So therefore, if I were to put them together, if I were to just bring this, because this thing multiply by this thing, so I'll just multiply it in, so I have something like this. Ta-da! So this thing over here is your this thing, and it should be smaller than infinity. Alright, where e is also equals to, alright, your this thing over here, your BIBO stability stuff. You see? The one that I'll just prove to you in the BIBO's video. Alright, where we go all the way just now when you just watch the video lah, alright. Just watch this thing, l6v7. If you need it, alright, if you need it. Alright, so this thing over here is the one that we have just shown you lor. So as long as your a1, alright, for a1 to be smaller than 1, alright, you're considered BIBO stable. And that's all it is lah. Alright, because why? It's because if your a1 is larger than 1, alright, this means you are outside of the unit circle already right, you're outside the unit circle already. And if exactly at 1, or exactly at 1, at this point, if your a1 is exactly at 1, alright, 1 minus 1 is 0, 0 divided by this thing will become infinity, and you will become unstable also. So therefore, in this case, your a1 shouldn't be 1 also. It must be smaller than 1 in order to be kept within this particular unit circle over here. Okay? So I think I'll just leave you to that. And this is why also they say that a1 must be smaller than 1, not smaller or equals. Because if it equals, you're also going infinity. Alright? So I think I'll just leave you to that. And lastly, repeat again, your a1 must be smaller than 1 in order to be BIBO stable. I mean BIBO. Did I say BIBO? Yeah, BIBO. Anyway, yeah lor. So this is the proof to this example where we have used the things that I've just done. If you haven't watched this example, you just watch this now, and then you will be more better to interact with what we have just done. Okay, so I think this is it for the BIBO's part.